output. There are four types of data in PLC usually. So, four types. The engineer, if he want to transport these four types of data, he must build a database for every type of data, like rice, fruit, and fish. Here is the three types, so we may need 3 trucks. And here are 4 types, so we must build 4 databases. Each database can hold one type of data. We have 4 types, so we have 4 databases. This work should not be done by us. This work should not be done by us. It is the PLC engineer's job. In his system, he must build 4 databases for different data type. For example, we have 2 points here. This point, PZI100. What is the type of data? Which type?
AI.
Which? AI. Analog input. So maybe this one for AI, and this may load here. This may load here. This, which type of this? Digital input. Yes. The first one may be for the digital input. So this data, this value should be saved here. This is his job. What should we do? After his configuration, there are 4 databases in the PLC, and we need to do the mapping. We need to do is mapping this 4 databases to our system. Mapping. Map. The map means copy. Holy. That means he has 4 databases. In our system, we must have 4 databases. And what is this like? In our system, is the same. That is map. This number of database determined by him, not by us. If there are 4, we have 4. If there are 3, we have 3. That's the map. So, step 2, we map this database in our system. That's our job. That's our job. We map this database in our system. The database in our system, we call it what? SCADA controller. So this mapping controller is our SCADA controller. This is step 2. This is we should do. We map the database in our system. In our system where is this 304 database? In our real-time database. So step 2, we configure the mapping controller in our real-time database. That's step 2. Now let me do it. I return to the quick builder, and I will build the first controller. I choose here, controllers, and add item. Let me select this type controller here. Okay, I gave it a name. Maybe number 1, controller number 1, and some description. Okay, and the important set here, channel name. For example, that means you should tell the driver. You should tell the driver of this truck which road you should choose, which road you drive, which road you drive. So here, we tell the driver which road. This. And the system will recognize this is the Ethernet road. So it needs an IP address for where? For the PLC. This IP address of the PLC. For example, we have no PLC here. But I have a simulation software in my computer, and I can make a virtual PLC in my computer. So the PLC device, in fact, is in my computer. So here I will enter my own IP address, and let me see. What is my IP address? Okay, here. This. And 5, 30. That's my IP address. That means our server will communicate with the other device. Which IP address is this? Through the Modbus channel. Okay. The next important parameter is here, data type. It determines which type of data you map. Here, there are 2 points in the PLC. There are 2 points in the PLC system. One is this, and one is this. But here, we can only choose one type. That means if we want the both point, we should build how many controllers in our system? 2. Because there are 2 types. If there are 4 types, how many? We must build 4 controllers in our system. Let me do this one first. This one. This one. The DI first. So I choose this type, digital input. And after that, I have finished my configuration. It is very simple. You just to set here which road you want to drive, the address. If you are not using the Ethernet, type, you may set here. This parameter is very important for the serial communication. The PLC station ID, that means the device ID of the PLC. Every PLC have a unique device ID, and we should set this the same as the actual device ID of the PLC. And in our experiment, in this example, it is not so important, so I state 1 here. Okay, now I have finished my first controller and download. Okay, that's step 2. I just built one mapping controller. Any questions? Can you understand what? Can you understand it?
IP address is the IP of your of the PLC or
Yes. The one I want to connect with. Yes. His IP address.
so
This is his IP address.
what about PLC station? Can you explain again? PLC
This.
station? Yes.
If this PLC station ID is very important for serial type connection. This type. It is very important for this type. Every PLC have a device ID. And it is set by the PLC engineer, not by us. For example, the PLC engineer set 48 to this PLC, and here, if we want to communicate with the PLC, we must enter what here? 48. Yes. We just keep the number same as the PLC's device ID. It's okay. In this example, it is not so important, but in the field, in your work, you just keep it the same as the PLC's device ID, and every PLC has this ID.
So this information, may I ask the PLC engineer?
Yes. If you are the PLC manager, you should know it. If you don't know that, you should ask them or ask him. Any questions?
What is the dynamic scanning?
What?
Dynamic scanning. Yeah.
This.
Yeah.
What scanning?
Live nó scan chất bóc.
Both dynamic scanning.
This one.
Bị đâu
Oh,
fail
the
anh.
dynamic scanning. Okay. Let me see how to explain. If you are not check that, that means the map machine always receive the data from the source machine, source controller, the map. This is the map controller, and this is the source controller. The not dynamic means the source controller always pass data through the connection to the map controller, and map controller receive this data all the time. And if you check this, that means what? That means usually this data flow are not exist, and usually maybe the source controller will transfer the data to the map, to the shadow of controller, to the map controller just once. If the data just keep it here and not changed, the password will stop. Only when the data change again, the password just start.
Only change data.
Yes. It mean so it is a very good function.
What is part number?
What?
Part number 1. Back of IP address.
On the right side.
Right side.
Yeah. In 502. Right.
Port number.
Yeah.
I don't know. we just leave it. If you choose the Ethernet as the connection type, and if you enter the right IP address, and this port always be 502.
Okay.
Any questions? If what?
Next, we will talk about the Markino alarm limits and fail alarm limits. I want to know how to calculate, how to choose the number for the alarm limit.
Alarm
Number,
limit.
yes.
Yes, it can channels when the
You want to
the channel
set
is
the
down.
alarm trip point.
yeah, how to set the Markino alarm limits and fail alarm limit. How to choose the number.
What alarm? What alarm limit?
The alarm limit, fail alarm limit is for the channel when the channel fail, right? The controller fail.
Oh, this
Yeah,
4 alarm limit
yeah.
and Magrino alarm limit. It is the unit. The time base is seconds. And this is 25 seconds, and this is 50 seconds. Fail alarm limit. That means if the map controller can't receive the data from the source controller, he will wait for what? He will wait for 50 seconds. If in this 50 seconds, the mapping controller received the data again, and there is nothing. But if after the 50 seconds, this our controller here, the mapping controller here, still can't receive any data from the source controller, then there will generate a system alarm. In this display, and you will know there is something wrong in the communication. Okay, let's have a break. Let's have a break. We will be back at 11. Okay, 11.
cái ngưỡng nó không đến mà theo đây cái ngưỡng nó có thể làm cứ mọi người thắc mắc cái này nó scan
Cái này giống như là tham ao request.
tham ao request đó, cái đây nó cho cái gì cũng có đây nó scan mà lừa đọc chỉ trong cái đây scan trong cái tài liệu Steelbook nguyên một đọc slide này ra lừa đọc chưa
Nhưng mà mày phải xem cái
Ờ, không.
เรื่องการไม่มีคำว่าอะไรที่เรื่องอะไรก็เดือนนี้มันก็เฟลบอกแค่นี้แหละ
โมเดลไงเพราะว่าเป็นมาร์จินอล
nó
ออริจินัลมันเป็นอะไรให้
เฟล
cái này
เฟลตัดไปเลย
cái này
cái này cái này
จะได้
มันต้องมารีเซ็ตพอร์ตก่อน แต่ถ้ามาร์จินอลก็คือถ้ามันกลับมา แล้วมันก็จะรีบูตกลับมา
ก็คือผลว่ามันแซมปิ้งค่าไปแล้วก็ค่าส่งภาพไปของค่ากลับ ถ้าส่งไปกันก็โอเคถ้าส่งไปแล้วไม่กลับมันจะรับเป็นเด็กครบ25 ครั้งมันจะขึ้นอะไร
อ๋ออันนี้คือกระบวนการ
คิดเป็นอัตราส่วนก็คือ25%ไม่กลับ
25%โอเค 25%50%ตั้ง 10% เฟลก็คือถือว่าเฟลไปเลยที่เขาไม่ได้ตั้ง
ไปดูหน้าแคปชั่นเขาก็จะพูด
Kéo nó buồn nó buồn.
là gắn cái card cái card của BK cái gắn cái card có cái cổng 485 232
là
này
server mình nói về
ตอนนี้คือ
เหมือนเป็นจำนวนแบบ
tên là
จำนวนแบบเป็นจำนวนแบบคือได้25แล้ว
เนี่ยมันจะนับตรงนี้ใช่ไหม
ใช่แล้วใช่แล้วก็เคยจะเอาเลยแต่ว่าไอตัวอารามเนี่ยว่าเป็นเปอร์เซ็นต์หรือที่เป็นตามส่วนไม่ใช่โมเดลมันเลยไม่ได้บอกไว้ว่ามันอารามไปแล้วใช่ไหมแต่ว่าพอว่าในเวิร์กมันเปลี่ยนแล้วแล้วส่งไปรับ25มันจะลงเรื่อยๆมันจะขับเข้ามาสู่สถานะของเซ็ง
อ๋อ
แต่ว่า
ที่เลยมองว่าเป็นเปอร์เซ็นต์ใช่ไหมเพราะว่ามันต้องลดลงเรื่อย
ใช่มันไม่ได้แบบว่าไปคาดหวังไปอย่างที่บอกถ้ามัน50 ปุ๊บอะมันจะไม่มีคาดหวังมันจะแดงถ้าแดงจะต้องมากกว่านี้
ๆก็เลยมองว่ามันเป็นจำนวนครั้ง
เดี๋ยวเรา
เป็น
ลองเก็บเลยที่มีคำถามหรือเปล่า
ถามแต่ผมก็ยัง
ไม่รู้เรื่องเดียวไม่เคย
how for the fail limit this one is alarm is time of alarm or percent of alarm on the point that
tao tao biết
The fail means on unit to fail. So this one is
just the trip form, just the
into the stator display, and the stator is what? Failed. It is failed. Someone just asked me what is this 2 parameter. This 2 parameter used for. Now, fail limit. This fail is this red light. It means the communication have some problem, and it is not very good to work. It is failed. Why? I just built a controller and download it, and there's no error. Why this controller failed? Why? This failed stator means our database, our mapping controller can't receive any information from the source controller. And why can't? Why can't we? Why can't this controller can't receive any information from the source controller? Why? Why this failed? It's very simple, because there is no source controller now. There is no PLC. So we just build the map controller, but there is no source controller. So after 50 seconds, it still can't receive any information from the source controller, and it shows us failed. So next, I will make the source controller online. How? I have a simulation software in my Drive C, and I will run the application. In my students, yes, here, student folder, and this is a Modbus simulator, software, and it can virtual PLC. It can virtual a PLC. So let me click open this folder and run this application. Okay, the application is running, but the status of this application is off. So next, I must check this, and let the simulator program connect with our system. Let me wait for a minute.
Không có sợ đâu. Ở đâu? Biết đâu?
Anh chỉ biết ngày mai nó kết nối.
Hold on just 1 minute. Let me see. Okay, okay. If there is this word normal, it means this simulator program can connect with us normally. And that means the program can communicate with our system. So the PLC controller is online now. Then I must build a database in the PLC. I must build this database in the PLC system. Because this PLC is online, that means you can, it's power on, but it has no database. As a PLC engineer, I must build this database for the data. Okay. What type of data? Okay, here. Digital input. So I built a digital input database here. This status, input status. I choose this. This is a database. This is a data table in the PLC system, and you can find how many? 24 units for the data. One unit can store one data. So there are 24 units. That means this database can hold how many values? 24. Yes, 24. Okay. Then let me see this data. And this is okay now. Now someone asked me these two parameter here, and we just see them at the configuration form here. What is original and what is failed? Let me show you. If I close the program, that means the PLC is offline now. And we see here, here is three very important parameters. The top one is total requests, and in the middle is total error, and the last is the error in percent. These three parameter is very important to show you the communication situation, and this is very important for us to view. And let me explain this. What is the total request? After we download the controller in our system, and that means there is a map controller in the real-time database. Its name is CON001. This. After we download this controller, the system will check the mapping controller can communicate with the source controller all the time. For what for? Every 1 minute, our system will send a request to the PLC, to the source controller. A request. This request have no contents except we want the PLC system give us a data. This data means nothing. Just give us a data. If the data can be received by our system, that means what? The road is very smooth. the way it moves, and we can communicate with each other well. If we send a request out and wait for what? Wait for a while, but there is no reply. Then the total error will plus 1. This is the total request. Until now, we have sent 5 requests to the PLC, to the source controller, but 5 requests, we only just received 3 data, and the 2 are missed. So there are 2 errors, and this, the last parameter. That means this. How to see? This in percent. So if you can see after 25 seconds, we can't receive the data from the source controller. The state of our mapping controller becomes original. That's the time limit. If we keep waiting, and the errors in percent grows rapidly, and this light will turn to red, and it will show you the word failed. This is the failed limit after 50 seconds. So we can see if the communicated state is right or wrong through these 3 parameters. And now it's not okay. Because the error in percent grows. Why? Because I just closed this program, and the source controller is offline. Now let me open this. Okay. Then we can see the error in percent. It's lower than time than right now. Then I build the database, status database. Okay, here. That's all of our controller configuration. We have 2 points. One is the digital input point, and we've just built both database in PLC system and in our PCAS system. But we have 1 point left here. This is an analog input. So as a PLC engineer, he should build another database for the analog input. So I choose this selection, and choose this one, input register. That means the analog input. And build the other database. There are also 24 units in the database. That means in the database it can store 24 analog values in the database. Okay. Now, as a PKS system engineer, what should I do? This is controller 1, but this controller 1 hold this type of data. What should I do now? I must create another controller which to hold the analog data. So I choose controller and create another here. Let me give it a name, controller number 2. Okay. Don't forget to tell the driver which road to drive, which road. Did I just build another channels? Why? Why? Another controller. Do we need another channel? If we don't, why?
Have the same.
Because there is only one physical connection. So in the software, there is only one soft channel. And we just have built this channel. So there is no need to build another. If you have another physical connection, you can build another channel. But in this example, we only have one connection, so we just use this channel. Here, tell the driver, drive on this road and enter the IP address of the PLC device. Okay, then this is very important here. Data table. What type of the what type of the data does this controller hold? Maybe this input register. That's analog input. And okay, finished. We download this controller to our real-time database and it's okay. Let me check the status of the controller number 2. This is controller number 2. And the error in percent is 0. That means it's okay. It's okay. Let me create a database. I just have created this database. Okay. Now the step 2 are finished. We just have 2 points to transport from PLC to our system, and this 2 points means 2 types of data. So we just create 2 controllers for the 2 types of data. And now the step 2 are finished. Step 2 finished. Now, step 3. After the controller configuration, what should we do next? The products from CTA are transported by the driver to here. That means this production may be stored in the CTB, and the products have been transported to the CTB, and they are being stored in 4 different warehouses. 4 different. Maybe there are 4 controllers. The controller is like a warehouse. We can store the production in the warehouse. 4 warehouses. We want to sell them in the supermarket. We want to sell fruit, rice, and fish in the supermarket. What should we do? How should we sell? we must put every unit of products into a packing box, because you can't buy so much fruit or so much rice once. You just can buy a little bag of rice. So we must put the production, put unit of production products into a packing box. On the box, we should also mark the name, the type, the production data, the shelf life, and so on. After that, we can put them on the shelf in the market, and you can buy it home. In our system, we have to do the work like that because we have 4 mapping controllers here. We have 4 mapping controllers.